Hello, so today we are doing this problem, Leetcode problem called reach a number. So the problem states that we get a position. We are standing at position 0 on an infinite number line, and our goal is um, to reach a position target that we get as input. And on each move, we can either go to the left or to the right. And during the nth move, when we are starting from 1, we can take n step. So during the first move, we can go 1 step. During the second move, we can go 2 steps. During the third move, we can go 3 steps. And these steps can be either on the left or on the right. And so we can go to negative values and we can go to positive values. Also, the target can be negative or positive, so it's between this range here, and it's not 0. So let's see how can we. So the goal here is to return the minimum number of steps we can do to reach the target that we get here. So let's see how can we approach this problem. So the main so what we are going to do is, let's first just try a couple of examples and see how this can be solved. So if the target is 1, then it's a non-zero value, so it's not going to be 0. If it's 1, then we can just do the first step, which the value is, remember, the value of a step is equal to n. So this is the first step, so its value is 1. And so we'll just reach it in 1 step. If the target is 2, then that means that we can do the first step and the second step, which will be basically 1 plus 2, which is equal to 3. So that's more than the target. So what can we do? We can like go to do a third step where we go to the left. And so if we do a third step left, so these are right, and this one is right. So that would mean we get 1 plus 2 minus 3, which will give us minus 1. So that doesn't seem like to lead anywhere, really. So let's try instead. So this is one option. We're just exploring to see how can we solve the problem. The option 2 would be to continue the third step on the right. And that would mean we will do 1 plus 2 plus 3, which would be 6. Now, if we do this one and continue and do the fourth step to the left, that means we will do 1 plus 2 plus 3 minus 4, right? And so that would be 2 exactly, which is we reach the target. So if we go this route, doing the first step right, the second step right, and then the third step right, and the fourth step left, then we'll reach the target in 4. So let's see if this one gives us a smaller number. So if we do this one, well, one option is we can go fourth step right, which would mean we will get minus 1 plus 4, which would be 3. So we are still different than target. No need to continue further because we already found the min here that reaches the fourth step, right? What if we go fourth step left, then we will increase this value to be minus 5, and so that's also not good either. So that means this was a good solution. I can go and try target 3 and target 5. But if you keep doing this, when I was solving this problem, I kept doing these examples, target 1, target 2, target 3, target 4. a pattern will be clear. And then if we think a little bit, why is that pattern as so, then we can realize how can we solve the problem. So this is a good trick when solving a problem that you don't know where to start. Just start exploring lots of examples and see if a pattern emerges. So what's the pattern here? The pattern here is that if the value is bigger than target, which is the case here, then what we can do is take the diff to be equal to the sum so far, which is this, minus target, which in this case will give us 3 minus 2. In this case, so let me just... So basically what we... So basically at each target, at each step, check sum if it's bigger than target. If sum is bigger than target, then we can calculate the diff, which is equal to sum minus target. And check if this value, so this value is either odd or even. So let's call this, so if diff is even, then like the case we found here where it's 6, then we know that we need to go just to the left somewhere, and we can find the solution. So we can either put -1 here or -1 here, or -1, just -1 before any of the numbers, and we can find the solution. Then just make one of the moves to the left, and we will reach target. Now, if diff is odd, then there is no way we can reach the target by moving left right away. So we just continue moving right until reaching an even diff, and in that case we can just use this, right? So, but why is this the case? Why is it when the diff is even, we can reach the target by going left once? Well, so the thing is, if we are at this position, like here, then if we are here, and if we move to the right here and say target is here, so if the difference is even, then that means we could just go like this, something like this. So we can just go to the left here, and then go back, and reach target this way. So basically we can do 2 tours. So we can do moves that are 2i, and to find the value where we can move to the left, which is I, then this diff has to be divisible by 2. Has to be divisible by 2, right? For this math here to work out, so it has to be divisible by 2, and so that's why when it's even, we just can say that that we found the minimum number of steps, and if it's odd, we could just continue continue until we find an even difference. So yeah, so that's the intuition. Let's try to solve this. And so we need a sum here, and we need a value that counts the step. So let's call that k. And one thing is, if the target is negative, then we could just like solve the problem for positive, and it will be the same thing, except that all the positive ones would be minus, and all the minus ones would be plus in the real solution. And so we could just say target equal to the absolute value of target, and we can go while S is the sum is less than target. So while we haven't reached the value equal or bigger than target, in that case, just keep increasing sum and keep increasing k. Just keep moving to the right, basically. And so that would mean S plus k and k plus 1. So the sum is every time at each step we add the value of the step, right? And now if we get out of that loop and we have the sum is different still than target. So if it's equal then to target, then we found our solution. In that case, we can just return k minus 1. Why am I doing k minus 1 here? It's because if we exit the loop, it would have been that we already did k, an additional k plus 1. So I do minus 1 to return the number of steps. So what did we do here? So we said that if it's odd, if the difference is odd, just keep increasing. So let's write that. So while the difference between the sum and target is odd, which means it's not divisible by 0, then just keep going to the right. So that would be k plus 1. There's only one case that we need to deal with here, which is what if we didn't enter this. Actually, we don't need to deal with that case since we must enter since the value is not 0. So we could just return this. But if we want to handle the case where a target is equal to 0, then we can just say if k is bigger than 0, we can do that. Otherwise, it's still 0, then we don't want to return minus 1, so we can just return 0. Let's submit this and see if it passes. Okay, this passes. I want to simplify this solution a little bit more. So instead of doing these 2 while loops, we can just get away with 1. So let's just simplify this a little bit more. So target 0. So while S is less than target, notice here we are doing the same computation, right? So we can just move this condition up. So either that or S is still different than target and the difference is odd. And if that's the case, just keep increasing. Otherwise, when either of these conditions is no longer verified, when neither of them is no longer valid, we can just return the response. So let's see. And the solution passes. That's it for now. See you. Bye.